I'm here in sunny California, but I want to say hi to everyone, no matter where you are in the world. Really happy you're here. My name's Andrew Scheuermann, and I'm going to be talking about a multi-dimensional approach to measuring web performance. A little bit about me. I come from a non-traditional background. I actually got an undergraduate degree in business management, and then I went to a boot camp. I'm currently a senior engineer at Airbnb. I've been in the industry for 6 years, at Airbnb for 3 years, and as Katie mentioned, I've been redefining how we measure web performance for the past 1 year. And in my spare time, I like to cook, read, and play board games. So we're all here because we want to make our websites fast. We're going to hear some amazing presentations on how to do that, but I'm going to talk about how we measure web performance. People often say things like, my site loaded in 5 seconds, or I increased my page speed by 10%. These statements can be a little misleading. They can be a little confusing because load is not a single moment in time. In reality, there are multiple moments that affect if a user perceives your site as fast or slow. So I think we should stop talking about performance in terms of a single metric because it misses the nuances that are very important to users and can make or break the actual performance of your site. So to illustrate this, I'm going to load a page from Airbnb. This is the listing page where you can see a home that you're interested in staying in. Here we go. We've requested the page. We're waiting for a bit. Something has rendered. The fonts have updated. The final image has rendered, and now the loading state is gone. As you can see here, there are multiple moments that provide visual cues that something is happening to the user. And if you can take one thing away from this talk, I want it to be that multiple moments matter, and you need to measure them. So at Airbnb, we used to measure, report, and work on improving a single metric called time to Airbnb interactive. This was different than Google's TTI metric. Our metric measured when the initial JavaScript bundle is parsed and executed plus 1 set timeout. In React terminology, it's component did mount plus 1 timeout. When I started working on my page's performance, TTI was pretty slow, all the way out here. I spent a lot of time improving the metric, sending down less JavaScript, and breaking one large task into smaller tasks. Those were good improvements. But I also did some questionable things. For example, I loaded non-essential above the fold elements asynchronously. So if you can see, this little heart icon and the share icon would pop in later asynchronously, leading to a little bit of cumulative layout shift for the users. It was a little weird. I also loaded the below the fold sections asynchronously. This means that if you loaded the page and you scroll down, you'd see a bunch of spinners, and that's not the best experience, but it was what I was incentivized to fix to improve this metric. So my performance improvements were a little bit of a mixed bag, some good, some bad. But more importantly than what I did improve is what I didn't improve. So I didn't improve time to first paint. I didn't improve when the primary image was visible. And I definitely didn't have any time to improve performance after the TTI metric was reached. So the problem was that our current system, and your system might be doing the same thing, incentivize us to only improve one metric. We needed a new system, one that measured and improved multiple moments that matter to users. And you may be asking yourself, isn't that what Chrome Lighthouse is? Chrome Lighthouse is an automated tool for improving the quality of web pages. You can run performance audits as shown here. As you can see here, it records 6 user-centric performance metrics, and it gives you performance recommendations on how you can improve. But Lighthouse was missing one key feature for us. It doesn't measure real user data. At the end of the day, we want to know how fast Airbnb is for real users on their various devices and their different connection speeds. For us, measuring real user data was a critical requirement. So we built something very similar to Lighthouse, but with real user data. So I'm going to talk to you about how we did this and how you can do this at your own company. First of all, the requirements that we had. As just mentioned, we want to measure real user data. We want to capture multiple performance metrics because that's how users experience the speed of our website. And finally, we want the system to be comprehensible. We have over 200 different pages at Airbnb, and our old metric was seconds-based, so it was simple to understand. We didn't want to introduce more complexity and have 200 numbers times 3 metrics or 4 metrics. That would just be too much to maintain. So we had to keep things simple. We set some requirements for which metrics we were going to measure. And I really appreciate Erie's talk about this because we're telling a lot of the same story. In fact, we both recommend that you read this user-centric performance metrics blog post by Phil Walton. It was really influential in our performance, it was really influential when we were deciding which performance metrics to measure. In this blog post, he recommends that you pick the performance metrics that answer users' expectations. They have expectations like, is it happening? Is the page loading? Is it useful? Is it usable? And is it delightful? The second requirement was that we had to have comprehensive browser coverage. Only measuring performance metrics in one browser was a non-starter for us. So we need to cover as many real users as possible and their various browsers. The final requirement was that we needed to support performance measurements for direct requests, which is when you first load the page, and client-side routed requests, which is when the JavaScript for a subsequent page has loaded and you can transition to that page immediately. We have to measure both direct and client requests. So we looked at all available metrics and we found only 4 that met our requirements. Time to first contentful paint, time to first meaningful paint, first input delay, and total blocking time. Now you might be thinking, wait, didn't I just see a big thumbs down by time to first meaningful paint? What that was indicating was that time to first meaningful paint is no longer being used in the lab, in the Chrome Lighthouse lab. But we have a way that you can measure this actionably and accurately in the field with real user data, and we're going to talk about that. So we're going to see what these metrics look like to real users, and then we're going to talk about how you can gather them as engineers. First, time to first contentful paint. This answers the user question, is it happening? When you load the page, it's the time from navigation start to when something is visible. This is a very important visual cue for users that the page is going to be fast. Next is time to first meaningful paint. This answers the question, is it useful? And it measures the time from navigation start to when the meaningful element is on the page. Now, one of the challenges about measuring the meaningful element in the lab is you don't know what's meaningful. But in the field, we have devised a polyfill where you can simply add an ID of FMP target to any element on the page, and our polyfill will measure how long until that element is visible, and if it's an image, how long until that image source has been downloaded. The third metric is first input delay, and this answers the user's question, is it usable? Now that the page has loaded, users are going to begin interacting with it, and first input delay measures if that first interaction is slow or fast. After users have began interacting with your page, performance still matters. In fact, total blocking time is a metric that we never stop recording. If you introduce blocking JavaScript at any point in the page lifecycle, this metric will capture it. So users are interacting with the page, and total blocking time sums up all of the blocking tasks, which can cause noticeable jank and frustrate your users. So to revisit this film strip, we're going to illustrate what we measure with these multiple performance metrics. Time to first contentful paint occurs here when something is visible. Time to first meaningful paint occurs here when the meaningful element that you've determined is visible. First input delay happens whenever users click on the page. And total blocking time is measured from first contentful paint throughout the entire page duration. So for a single page, we never stop measuring page performance. And because our system supports direct request and client-side routed requests, we can measure the entire performance journey. At Airbnb, you load the page, you search, you find some dates, and then you book it. We never stop measuring page performance. Now you can actually see this live. If you append the PPS equals log to any website or any page at Airbnb, you will see this output in your Chrome console. This is just kind of a fun thing for you to play around with this. Now, as I mentioned, two of our requirements were comprehensive browser coverage and support for direct and client-side routed requests. We had to build our own polyfills for time to first contentful paint and time to first meaningful paint to support this. And we extended Chrome's first input delay polyfill so that it could be reset on subsequent page loads. These polyfills are battle tested. We've been using them for 6 months at Airbnb, and they're only 2 kilobytes of code. We have plans to open source this, but if you absolutely can't wait, you can open up airbnb.com right now and simply copy this script from the head of our document. So checking back in on the system requirements, we have completed 2 of the 3 requirements, so we're looking pretty good. But the final requirement was to make this comprehensible. So one of the challenges about having so many performance metrics is how do you incentivize people to improve the right ones? Erie's talk showed that there are maybe 15 or 20 different performance metrics you can choose from. We've chosen 4, but how do you report all of these and make sure that people improve all of the metrics that matter? For us, it was important that we reduced all of these metrics into one single number. I love this quote because what is measured and reported improves exponentially. I've seen this personally at Airbnb, where whatever we set goals on and tie performance bonuses to, that is what improves. And other things maybe improve, but not as a first-class citizen. So for us, we had to keep our reporting simple. So for us, it had to be one single number. So we have these 4 metrics, and I'm going to talk through how Airbnb turns these into a single number. But I really want to reiterate that you can take a different approach. The most important thing is that you can turn multiple metrics into one single number. Performance values generally follow a log normal distribution. They're clustered around a median value, and there's a long tail of really slow values, which is shown here in this chart to the right. For us, the 95th percentile median value for time to first contentful paint is 5 seconds. This means that if you have a time to first contentful paint of 10 seconds, you're 28% along the curve. Or put in another way, you're faster than 28% of values. If you have a time to first contentful paint of 3 seconds, you're faster than 67%. For this individual metric, your score is 67. So what we do is we take the scores for the 4 metrics, apply a weighted average, and add them together. And this outputs a single 0 to 100 score based off of 4 or whatever number of input metrics. Now, I'm going to share a link later, but we've actually shared this calculator so that you can run these for your own pages. So checking back in on our requirements, we've now met all 3. The page performance score is what we measure at Airbnb and to measure page performance. We're measuring multiple user-centric metrics with real user data, and we're outputting a 0 to 100 score. Checking back in on the similarities and differences with Lighthouse, the page performance score uses real user data. It has 100% browser coverage. So it's really good for measuring how faster site is for real users. Lighthouse, on the other hand, runs in the lab, and it gives you performance advice on how to improve the performance of your page. And in the middle, the overlap between the two is there's a 0 to 100 score, there are multiple user-centric metrics, and there's a correlation. And by that, I mean, if you improve a metric like first input delay in the lab, it will improve for real users and vice versa. So we use both page performance score and Lighthouse at Airbnb. So let's look at some case studies of how we've used these two together. While we're looking at these case studies, we're going to be looking at 95th percentile values and real user data. The first case study is when we introduced a service worker at Airbnb. The way that this works is the first time visitors would download the code for the service worker, and repeat visitors would immediately see this app shell when they opened the site. We ran an A/B test for about a month, and these were the results. In this film strip that I've created, we can see the non-service worker treatment up top and the service worker treatment on bottom. So without a service worker, people get to time to first contentful paint in 4.5 seconds and time to first meaningful paint in 6.5 seconds. With a service worker, you see time to first contentful paint 1 second faster, which then kicks off a client-side request for the page. So time to first meaningful paint is considerably slower. The numbers bore this out, and contentful paint was 20% faster, meaningful paint 60% slower, and our page views were 1% higher, and our bookings were 0.6% higher. So overall, this was a good experiment, but we still have some work to do to improve that first meaningful paint. The second experiment we're going to look at is the calendar. So we're always redesigning things at our company. And we designed a new calendar. We ran an A/B test for about a month. And we noticed that the new calendar was introducing performance regressions in the form of increased total blocking time. This indicates a performance regression caused by the calendar. We dived into it and discovered that we were unnecessarily re-rendering the calendar when users interacted with it. So after we fixed the re-render problem, we saw our total blocking time at the 95th percentile reduce by 1.5 seconds. Google Maps. So on the listing page, we show a map of where the home is located. It's located about 3/4 of the way down the page, and only 20% of visitors will actually scroll far enough to see the map. But 100% of visitors download and parse the code for the map. So when we ran Chrome Lighthouse for our page looking for performance improvement opportunities, it recommended that we reduce the impact of Google Maps. Everyone was downloading 600 kilobytes of code, but as I mentioned earlier, only 20% were scrolling down far enough to see it. So what we did was we wrapped that section that the map was in an intersection observer, initialized it in a loading state with a shimmer, and then when a user scrolled down to the map, we would load the code. After we instrumented the intersection observer fix, we saw total blocking time reduced by about 2.5 seconds. Now, the final experiment I'm going to talk about is client-side routing. As I mentioned earlier, one of the requirements was that we had to report client-side routing. One, because it's faster, and two, because we want to have a comprehensive view of the performance of our site. So on Airbnb.com, you can save homes that you're interested in, and you can visit all of the saves that you've saved in the past by clicking the heart in the bottom. So I'm going to click enter now, and we're going to see a film strip of the direct request and client-side request side by side, and see how these feel to you. Client-side route, you get immediate feedback that something is happening, and then they both end at roughly the same time, but the client route request gets there sooner. So all of the metrics got better, and page views went up by 6%. So because of this, we know that client-side routing is a better experience, and we know exactly how much better it got. So that's it for case studies. Let's talk about some learnings that we've gained from instrumenting page performance score at Airbnb. We've been using this for about 6 months, and here's what we've learned. First is that transitioning from a seconds-based metric is a difficult paradigm shift. People are, incorrectly or not, people are used to thinking about performance as a single seconds-based number. And they have an established map in their head about what is good, average, or slow. To ease this transition, build off of that map and map whatever your new values are and the appropriate ranges to their old expectations. This will really help you organizationally pitch and instrument a 0 to 100 base score. If you remember, we have created a time to first meaningful paint polyfill, but this requires that you, as the engineer, identify exactly which element is meaningful with this ID. If you don't add this ID on a page, we have no way of knowing what is meaningful. Now, the page performance score is based off of 4 individual metrics, and if one of those metrics is missing, the score is invalid. So rather than showing an invalid score, we show a score of 0 if the time to first meaningful paint found rate is less than 80% or some threshold that you can pick. This has 2 major benefits. The first is that a score is either valid or 0. There's no second guessing a score. And it encourages proper time to first meaningful paint instrumentation because no one wants a score of 0. Another learning that we had was the importance of meta metrics. The first input delay and total blocking time metrics are somewhat opaque. By adding meta metrics around these metrics, you can gain insights into where exactly your delays are coming from and how best to improve it. And our final learning is that we're still learning. The page performance score is in version 1 at Airbnb. We have these particular weights, metrics, and scoring system. But like Lighthouse, our approach is going to evolve as our understanding improves and as newer metrics become available. One benefit of transitioning to a multiple metric approach is that when you decide to add more metrics, like frame rate or some other metric, it becomes easier to transition to V2 because you're not having such a huge paradigm shift as you did at the beginning when you went from a seconds-based metric to a number-based report. So some of the key takeaways from my talk are that load is not a single moment in time. There are multiple metrics that matter to users, and you should monitor them for the real user data. And to keep things simple, you can combine all 4 of these metrics into a single 0 to 100 score with some pretty basic math. Here are some resources for you to learn more. This user-centric performance metrics blog post is amazing. You can reach out to me on Twitter. We have polyfills that are going to be open sourced soon. And we have this score calculator, which is available at this link. I'd like to publicly thank Gabe Lyons and Guy Ritger and the Web Performance Guild at Airbnb who all made this possible. And thank you all for attending.